Okay, so a couple classes ago we talked about graphing these quadratics using standard form, and now we're talking about using this thing called the vertex form here. And the vertex form, it's a lot, in a way, it's a lot easier to graph. You don't have to use that negative b over 2a to find the axis of symmetry. In fact, it gives you the axis of symmetry and it gives you the height. So you may recall from last lesson the axis of symmetry is just the h, and then the height is just the k. So it's just whatever the h and the k are is the vertex. We find the vertex very simple. Remember, the vertex is either the maximum or, in this case, the minimum points of a parabola. So that's what we're going to be learning about today. Let's talk about it. Here, I'll just read it. So graphing this vertex form of a parabola. The vertex form of a quadratic equation is this, where a is not 0. The reason the a can't be a 0 is, if you think about it, what would that do to this problem? If the a were a 0, even if you did the order of operations and first inside the parentheses you squared it, well, that times 0 would just be 0. And so it would just get rid of all this. It really wouldn't be a quadratic at that point. The graph is a translation h units horizontally and k units vertically of the graph f of x equals x squared. Let me break that down in simpler terms. Remember, f of x equals x squared is just the parent function. And so what it's saying is that when you have something in vertex form, see if I can put this here, that it's translating, or it's moving this graph, it uses the word translation, and it's moving it up or down according to the height. So if this was a 3, this whole parabola would go up 3. And if this was a 4, it would go to the right 4. And if it were negative 4, it would go to the left negative 4. So it's just a translation according to these. Up and down are left and right. So of this parent function. Now remember, there are other factors we already talked about. I'll just review it real quick. This idea that it can either also be a vertical stretch if it's greater than 1, or shrink if it's greater than 0 but less than 1, shrinking away from this vertical line. So those are also things that we can look at. All right, and it says the vertex is, well, what I went over is h and k. So simple. Okay, well, let's go ahead and let's graph some of these then, huh? It says graph this and compare it to the parent function. Let's see if I have a graph anywhere I do. So let me just write the equation so we can see what we're graphing here. That's always a nice step. And I'm going to write down the steps to solve this. I want you to also write them down in your notes. So if we had, what's the question? It's g of x equals negative 2 times the quantity of x plus 2 squared plus 3. Okay, so the first step would be to find the vertex. And remember how we find the vertex is we just take the h and the k. So the vertex in this case would be, now remember, the vertex has a negative h. There's a negative in front of that h. So whatever number you see in here, you have to take the opposite because there's a negative there. So if this is a positive 2, you would write a negative 2. And the k is the height. It's just a 3. So that's the first step. You just count from the origin, negative 2, up 1, 2, 3, negative 2, up 3. There's your first plotting point. Good. Okay, so after we do that, we'll choose points and substitute and solve those points. So let's write that down as a step. Choose points. Oops. No, I don't want to work from home. Substitute and solve. It really sounds like 3 steps, like I'm tricking you. It really is the second step. So the first thing we're going to do, we're going to make a little chart. And we're going to choose numbers. I don't know what numbers to choose. I'll just do a -3 and a -2. The bell sounded, but that's in the video, so don't leave class. Or if you're at home, you're not at school. It's okay. So we're going to substitute these in. I'm just going to do it on this page. I'll do the first one. And then the second one, I think we can do in our heads. So instead of an X, what will we input in its place? Well, the first number we'll input in its place is this -3, right? Because we chose, oops, I moved the whole paper. We chose this -3 to be our first number, so let's substitute a -3. And this side doesn't change from that point on. Just you put g of -3. That blue's kind of blurry, isn't it? Let me choose a finer point. So we do the order of operations, PEMDAS. Parentheses always go first. Right? PEMDAS, parentheses, exponents, multiplying and dividing. So a -3 plus 2 would be a -1. Everything else just brings down. After parentheses, we do exponents. A -1 squared is just a 1. Everything else just gets brought down. After exponents, we multiply. Should finish this. So a -2 times 1 is a -2. So if your output is if your input's a -3, your output ends up being a 1. I'll just bring this down. Okay, let's do another one. I'm going to try this one in our head. Let's see how we do with it. If our input's a -2, we'd have a -2 plus 2, which is 0. 0 squared is 0. A 0 times a -2 is 0. And a 0 plus 3 would be 3. Okay, so let's plot these points. If x is a -3, 1, 2, 3, y or g of x would be 1. If x were a -2, oh, we already did that one, 3. Okay, let me choose another one. Let me choose -1. If x is a -1, so 2 minus 1 would be 1. 1 squared would be 1. 1 times a -2 would be a -2. A -2 plus 3 would be 1. Okay. Okay, so there's something really cool I didn't get to show you because of the numbers I chose. So I'm going to choose one more. I'm going to go out of order and choose -4. Okay, -4 plus 2 would be -2. Squared would be 4. 4 times 2 would be a -8. A -8 plus 3 would be 5. -5. So if we did a -4, we'd have to do a -5. And here's what I wanted to show you. I hear someone knocking on my door. If it's you who are watching this video and saying, why didn't you answer the door? It's because I'm recording a video. They're not getting it. They're coming to my window. Okay, 1 second. Pause break. Hold on. I'm recording the video. I'm recording right now. Okay, that was an unusual break, but we're almost done with this video, so I did not want to start it all over. But so what you can do is you have the axis of symmetry, right? You already know the axis of symmetry is -2. I drew a pink line down to illustrate it. If you were to go down, let's say from the y-axis, 1, 2, 3, 4, 5, you can see that it's 2 away on the left. Well, then it's also going to be, since it's symmetric, 2 away on the right. So if you get one number, you can automatically get the other just by counting from the axis of symmetry. I should probably do one more just to illustrate this point. Let me do a -5. I'm running out of room here. So if I do a -5, that would be a -3. Squared would be 9. 9 times 2 would be a -18. A -18 plus 3 would be -15. Let's see, can I even do that one? So if we were to do a -5, we'd have a -15. So -5, 1, 2, 3, 4, 5. -15, 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, Kinda. It's off the map, but you can see if you were to extend the axis of symmetry that it's just 1, 2, 3 away, so just go 3 away, 1, 2, 3. And that's how that parabola would continue. Last step is just to draw the lines connecting the parabola. Okay. Connect the dots, draw a smooth line is what I'll call it. And that's how you would graph it when it's in vertex form. So how would I describe it? Because it says how, remember the original question is to graph it and then compare the graph to this parent function, right? How would I compare this parent function to what I just made? Okay, so well, one thing you can see is that the parent function's smiling, it's up. It's positive, this is going downward. So that would be one comparison, is it's going downward. Another comparison, let me just write that. So I'd say g of x opens downward. What else can you say about it? You could say the vertex. Remember before we did comparisons, we would say describe the vertex. Now we can say the vertex of G is -2 and 3. Okay, -2 and 3 units up and to the left. Or you could say 2 and 3 units up and to the left. And then you can see by looking at the question, there's a vertical stretch by a factor of 2, and then it's a reflection because it's negative. So it's a vertical stretch. By a factor of 2. So there are some ways you can compare it to this parent function that we compare everything to. One last thing I want to show you, and that's when you have this graph, something like this, g of x is to graph this one. Oops, we're running out of time.